Welcome. This video is going to be dealing with random rotation and random scale, which is really going to add those final organic touches to our scenes. As you can see, these objects look like they've been scattered around more in a hurry than before. We've got these big and small rocks, which are very fun to look at. Not in this next scene, but let's go on and see. Yes, there you go. In a following up scene, we've got this nice, majestic looking rocky landscape where it's going to be really fun to play with, because as we go through, you're going to be able to just, duck behind the rocks, and hopefully there will be some AI in here as well, and you're going to be just seeking and hiding between these rocks and shooting out at the AI, and that's all going to be really fun. So I'm going to show you how to randomize the scale and rotation in the lecture. Let's dive right in. So let's take a look at our world and see what problems we still have that we want to fix. Well, here obviously we've got a lot of debug traces. We're going to want to get rid of these eventually, but I won't do that just yet. However, we do have a little bit of an issue. Well, not an issue, but something that doesn't really make our level look polished, and that is that everything is in the same rotation. It's in this, all the props are the same scale, so it kind of looks very inorganic, like these things have just been dumped there. So we're going to work on randomizing a bit further in this lecture. We're going to change the rotation, change the scale, and make these radii correct, because if you look at this canister, it has a massive radius up to here of free space, and it really doesn't need it. It could be much closer to the other props, and that would make it look much more natural. So that's great. That's a place for us to start, and that is the first thing on our checklist, to add a randomized rotation. I'm going to show you how to add the randomized rotation. You are going to go ahead and add the randomized scale for yourselves. Okay, so for rotation, we don't need to expose any parameters in place actor, because rotation can be between minus 180 and plus 180. We're only talking about a yaw rotation here. Let me show you what I mean. If I go ahead and hit play, we're only talking about rotating it around inside this sphere. Obviously, we don't want it rotating and flipping up, because that's just going to look weird. So we're just talking about a yaw rotation. And within this sphere, we're perfectly at liberty to rotate any way we like, and it's not going to collide with anything. So we don't have to even check whether the free space will allow that rotation. So I'm going to go into tile.cpp, find my place actors script, and here where we've got find empty location, and then once we've found an empty location, we place the actor. Well, actually what I want to do is place the actor with a rotation. So in order to do the rotation bit, I am going to go in and add a new parameter here, comma, let's see, it's going to be for rotation, we're just going to use a float because it's just one axis of the rotation. And I am going to copy that down into the H file as well. Place actor with rotation, and then where I call it, for now I'm just going to put 0. So no rotation, because what I want to do, because compiling can take quite a while when you change the header file, is make the change to the header file and then initiate the compile and go away and carry on doing the coding while that compile is happening. Okay, so this place actor we have given 0 at the moment. We're going to have to give something more meaningful, but what are we going to do with the rotation once we're in place actor? Well, I'm going to go to spawned, the spawned actor, and using the arrow operator, I'm going to set the actor rotation. This obviously takes an F quaternion or an F rotator. I'm going to use the F rotator option, and then have a look at its default constructors. We've got one with pitch, yaw, and roll. That's the one we want. So we're giving it 0 pitch. We are giving it rotation, yaw, and we're giving it 0 roll as well. And that should do the trick for setting the placed actor's rotation. Then where we call it, we want to generate a random rotation, and I'm going to do this inside found. There's no point generating the random number unless we've found an empty space in which to put it. So I'm going to make a float rotation, or I'll call it random rotation, and I'm going to get that from fmath : rand range, and it's going to be between a minimum of minus 180 to positive 180 on the upper side, And let's just check that this is going to be returning. You see, it thinks it's got integers. So we want to be making sure that it's using its float version. So I'm going to make it point F and point F, which should make this into a float version of the rand range. Great. So that can give us any rotation, not just integer rotations in degrees. And that random rotation is going to be passed in to our place actor, like so. And I'm going to go over to Unreal, compile again. Hopefully this should be quick because the header file has already been done. There you go. Very quick, you see? So that's quite helpful. I'm going to go ahead, hit play, and have a look. Are we getting random rotations? Yes, it looks like it. They're no longer axis-aligned boxes, so we must be. And the same goes for the canisters. And let's go and have a look at this crate over here. Yes, also no longer, it's a bit askew, which is just what we're looking for. A little bit more organic feeling. So I'm going to go and check that off my to-do list, which means it is time for your challenge. Your challenge is going to be randomizing the scale. So let me talk you through that a little bit. You're going to add a randomized scale. That means exposing to the designer which scales are possible for your given asset. So for your given prop, are you allowed to scale it at all? And if so, by how much? And what's the minimum scale? What's the maximum scale? Assuming that 1 is the default scale. Use a sensible default. So make sure that the designer, if they haven't put anything in, you're not going to end up with tiny little props or massive props. And ensure that scaled over objects aren't going to overlap. Make sure that the test in our generate and test still works with your scale factor. And finally, a little bonus is set some sensible radii, because at the moment we've got not very sensible radii for the canister, for example. We've got way too much space, and we need to make sure that that's more sensible. So go ahead and tackle that challenge. Welcome back from challenge time. We are going to hit up this challenge ourselves. So where do we start? Well, I've said that we want to expose to the designer the minimum and maximum scales, or I didn't say in such words, but that's essentially what I meant. So with place actors, where the designer basically is fiddling with the blueprint, we want to give it a minimum and maximum scale. That is going to be a float, min scale, and as I said, sensible defaults, I'm going to give it a sensible default of 1, and float, again, max scale, and again, sensible default is going to be 1 because the wonderful things he does. No, because we, by default, don't want to scale objects. Not all objects can scale. For example, scaling the container doesn't make very much sense. If you scale the container, it's just going to look weird. Scaling rocks, however, and that makes sense. Maybe scaling sandbags doesn't make sense, but scaling rocks does. Okay, so I'm hopping over the arguments down into the C++. I'm not going to do anything with them just yet because I'm going to use my compile trick to compile the header while I am working on the implementation. So we've got the min scale, max scale, all good. Now, we're going to have to create that scale. I can't do it inside the found like I did with random rotation. The reason for that is because in order to find the empty location in the first place, we're going to need to know how big the object is going to be and multiply the radius by that size. So I'm going to generate a random scale out here at this stage. I'm going to say float random scale is equal to fmath : rand range. You've got the idea here. Min scale and max scale. And then this random scale, we are going to multiply by the radius to give the argument for find empty location. Because we want, obviously, if you've got an object that's going to be twice as big as its default radius, then your radius is going to have to be twice as big as well. Then we're going to have to pass that random scale into the place actor. So again, I'm going to have to make a header file change over here. Place actor is going to need a float scale. And I'm going to have to compile that jazz once I have correctly updated all the calls. For starters, I'm going to put it in place actor random scale and build. I'm going to build from within Visual Studios here. It's going to do the hot reload and everything. I do Control-Shift-B to do that. So have we got everything? We've passed the scale into place actor. It seems unhappy with it at the moment, but I think it just hasn't caught up yet. We've accepted that scale into place actor, but we haven't done anything with it, so we need to do something with it. I'm going to do a spawned arrow set actor scale, and you see that the only option here is scale 3D. And scale 3D takes an F vector. What could that mean? Well, if you've got your thinking hats on, you'll realize that scale 3D means that it can scale differently in each axis. In our case, we want to scale the same in every axis, so you've got a couple of options. You could be verbose and put scale, scale, scale in every bit of the vector. But you'll actually find that if you just put scale and no other arguments, and take a look at how this F vector constructor works, that was F12 to jump to the constructor, you'll see that when you give it one argument, it basically does that for you. It gives X, Y, and Z as being that float that you gave it. So that should do the trick. I'm going to remember my semicolons and hit the build button. And hopefully what we're looking at here is the ability to scale. That seems to have given me an error. So let's just check out that error. Saying it's failed to produce something. I'm not entirely sure why. I'm going to go and compile in Unreal just in case the error is transient. I've been having a few of those transient compile errors recently. I think it's just when it's struggling to write to the file. Okay, let's hit play. And hopefully we'll see that there is no change. The reason we're seeing no change is because we haven't changed anything over in our tile blueprint. So if we go to our dynamic terrain tile blueprint, we'll see that all our default scales are in effect, but we obviously aren't scaling anything. So let's see our scales actually work. I'm going to make our rocks scale up to a maximum of 5 times their original size. I'm going to compile and save, and I'm going to hit play. And hopefully we should see a few rocks which are big. Let's go and take a look. This rock is definitely bigger than it was before. I don't know about you, but I'm starting to get annoyed a little bit by all these red lines everywhere. Let's see. Not seeing many big rocks. I'm not sure what's going on there. It's probably to do with our radii being too large, and so it's not being able to fit the larger rocks anywhere. So let's fix up the radii as the next step. Okay, so tweaking these radii, the idea is that you go and find the size of the original model. So I'm going to do this for the container and then just use the values that I figured out earlier and just show you how it's done for the container. So for the container, I'm going to go to the top-down view, and here you can see the scale is 1 meter for 2 squares. And I want to basically see what is the largest radii that I need to protect from the center. So if I go 1, 2, 3, 4 meters, 4.5 probably, then I'm definitely going to be safe. So 4.5 is exactly what I have in my notes. I'm going to go for 4, slightly on the smaller side, on the tight side. So that's going to be 400 radii for the container. And then what have I worked out for the others? For the box, I worked out about 100. For the canister, about 50. It's very small. That's 50 centimeters, by the way. Then the rock is 150. Rock 1. Rock 2 is 250. So you can see these radii are much smaller than the defaults. The third rock rather is 250 as well. These are all approximate, and the sandbags are 250 as well. We'll compile that, save, go back into the map, have a look, and hopefully, there you go. We're seeing much less red lines because it's struggling less to place things. We've got our rocks that are now different sizes, and let's go through into the next world. In the next world, you can see a few really big rocks, which is exciting because they kind of make the scene look very beautiful. Look at this massive, majestic, beautiful rock with its really gorgeous texture. And we've got a few man-made obstacles around here, all rotated, of course, at random rotations. There you go. Massive rock in the scene over here, which is looking great, and it's got a nice radius around it. So we'll never block gameplay because we'll always be able to get around the perimeter of these rocks. They'll never be so close that they are blocking the road for us to progress. Okay, so that's pretty much tweaked the spawn radius. The last thing I want to do is remove that draw debug capsule. I don't think we need it anymore. Draw debug capsule has kind of served its purpose. I'm going to save, build. If I use the right key combination, go ahead and hit build, and hopefully that annoying green and red that is all over our scene will go away and leave us alone, leave us in peace. So we've pretty much, it should be a fairly quick compile, only change the C++ file. Let's go ahead and hit play, and there you go. It's also going to be much faster because it's not drawing these red lines all over the place. So there you go. We've got a scene full of rocks, a few man-made things, which I'm very happy about, and it's starting to look good. Now, in the next lecture, we are going to be looking at how we can add a bit of grass, luscious grass, to make our scene look less muddy and less repetitive, and I think that will add the final touches we are really looking for. One more thing before I go, however, is I'm not happy with having all these props still in the level, so I'm going to go for top-down from the first-person example map, and I'm going to zoom out to the level where I can see all my props. Let's see if they're all somehow together in the world outliner. They are all under cubes. I'm going to delete the cubes in the world outliner because we've got our own props now, thank you very much, and they're better. We have now got better props. So deleted the cubes. We've got the big wall in the arena. We want to get rid of those two big walls, get rid of the arena folder, get rid of the arena geometry folder. We've got the stairs somewhere as well. Let's get rid of those too. You can see we're really starting to have few things in the world left, which is just what we want. So I'm going to save, hit play, and there you go. We've got entirely procedurally generated first scene and every scene subsequent to that. So obviously you can tweak to your heart's content to get the right random selection of objects in your scene. But next lecture, we are moving on to creating some nice procedurally generated grass with all the correct level of detail. That's going to be very exciting, and I'll see you there.